My name's Arif Kahn. I'm here to talk to you about USB Type-C today. USB is the most ubiquitous interface you see in the digital world. It's used everywhere from PCs, phones, cameras, storage devices, you name it. It's been around for over 2 decades. The USB standard has evolved along the way, meeting speed needs as its generations have evolved from USB 1 all the way to Gen 3.1. Gen 2 was 480 Mbps, which was by far the most commonly used. Then Gen 3 came by with 5 gigabits per second, and now the Gen 3.1 standard takes us to 10 gigabits per second. While the speed has increased over the years, there's also been a proliferation of the number of connectors and cables that have come with it. And this has been the most frustrating experience for customers, to see different kinds of cables that are incompatible with devices. And even more than that is which way is up. Most customers struggle with trying to put a USB cable into its slot only to find that they've got to flip it around. Last year in August, the USPIF proposed a new specification called the USB Type-C standard. It makes the USB connector a flippable connector, so it'll work regardless of the direction you put it in. Very similar to the Lightning connector that you see on modern iPhones. In addition, this connector is able to support up to 100 watts of charging, so that you could use the same type of connector to charge whether a phone, an iPad, or something as powerful as a high-end MacBook. At the same time, this connector can carry information that's not just USB, but also display and other protocols. So it is the connector of the future. So how does this work? In principle, you've got a connector that's symmetric, has compatibility connections for USB Type 2, some cable detect pins, and some pins that we might visualize as receive, transmit, so that when this connector is flipped over, it appears in the same orientation and the device continues to work as is. While this looks simple mechanically, the electricals and the logic behind it are fairly involved. And Cadence has put together a solution that actually addresses this. So for a moment, if you imagine that this was your connector with all the pins straightened out, and you had USB 2 up here, that would talk to the legacy USB 2 connector, controller and PHY. And you had your receive and transmit lanes. So you had receive 1, receive 2, this would give you 2 lanes of USB, for example. But what would happen if you had the display port running as a 4-lane combination? You would take those lanes and drive them out this way. So that with 4 pins, you could have combinations of 2 USB lanes, or 1 USB and 2 display port lanes, or you could have 4 display port lanes altogether. Talking behind this big switch that connects to a PHY and controller for USB 3 display port. In addition, this has the extra pins that talk about the power as well as the cable connect logic that goes into additional alternate mode detection, or what we call the Type-C power controller logic. This works in conjunction with the display port and USB muxing. It also drives what's called the power management IC. The power management IC is the piece that controls the power delivery over this connector. This requires an interface to an external microcontroller that runs the software that drives the power stack. There's a lot of third parties like Google, et cetera, that are providing software stacks that will run on power management controllers. Cadence is happy to be part of this ecosystem and is working with a number of partners to provide a complete USB solution. For more information, please visit our website at ip.cadence.com. We look forward to talking to you next Wednesday again. Thank you.